In this video, I want to take a look at solving absolute value equations that contain two absolute value expressions instead of just one. So typically when we solve these, we're going to isolate the absolute value and then break it into two equations. The interesting thing here is I have two absolute value expressions, but the good thing in this example is there are no terms outside the absolute value expressions. So I just have absolute value equals absolute value. So I'm going to go ahead and break it down into two equations. I'm going to have 2x minus 3, and I'll equal the positive side here, so 3x plus 2. And I'll also have 2x minus 3 equals, and we'll do the negative side, so negative, or the opposite of our 3x plus 2. Let's go ahead and solve both of these equations independently of one another. So if we subtract the 2x and put it over here, it'll be x and minus 2, negative 5. So it looks like x equals negative 5 for one of my values. So let's go ahead and distribute that negative through. So 2x minus 3 equals negative 3x minus 2. So add 3x to get 5x, and we add 3 to get 1. So x equals 1/5. Okay, so let's go ahead and plug them both back in and just kind of make sure they work. So the negative 5 first. So 2 times negative 5 is negative 10. Minus 3 is negative 13. Absolute value of negative 13 is positive 13. So I'm going to go ahead and jot that down. So negative 5 on this side. 3 times negative 5 is negative 15. Plus 2 is negative 13. Absolute value is positive 13. So 13 equals 13, and that one works. So let's do 1/5 real quick. So 2 times a fifth is 2/5, and then minus 3 will be negative 13/5. Absolute value, 13/5. Okay, so 3 times a fifth, 3/5, plus 2 will be 13/5. Absolute value, again, 13/5. Okay, so both of these values work. So we can say x equals negative 5 and 1/5. Okay, so there's the solution set. Okay, so you probably saw this other property that I had. The absolute value of x equals the square root of x squared. So I want to kind of revisit this problem, and I want to do it a second way that I think is a little interesting. So I'm going to go ahead and rewrite it down here first. So I'll say the absolute value of 2x minus 3 equals the absolute value of 3x plus 2. And I have this absolute value of x equals the square root of x squared. So let's go ahead and rewrite both of those absolute values using this property. So I'm going to say 2x minus 3, and that's going to be squared inside a square root. And then 3x plus 2, that's going to be squared inside a square root. So when I have these two square roots equal to each other, I'm just going to go ahead and square both sides because I just care about this squaring business. So let's go ahead and get rid of those. And what I'm left with is this 2x minus 3 squared equals 3x plus 2 squared. Okay, so this is very interesting. So I've taken my absolute value equation and I have transitioned it or turned it into what appears is going to be a quadratic equation. Let's go ahead and square both of these. So 4x squared minus 12x plus 9. And that will equal 9x squared plus 12x plus 4. Okay, so let's go ahead and push all these terms over to the right side. So 0 equals 5x squared plus 24x minus 5. So when I factor this, I'll end up with, let's see, 5x minus 1 times the quantity x plus 5. And when I solve this, I'll get 1/5 and negative 5. Well, that's very, very interesting because 1/5 and negative 5 is exactly what we had here. So it's just an interesting way to kind of look at this problem, and maybe it's a new way, maybe you've not done this before, but instead of solving it by splitting it into two, we kind of change it using this property and then we solve it using a quadratic equation. So there's our first example of solving an equation with two absolute value expressions. In this second and final example that we're going to look at, you'll notice again two absolute value expressions, except now they have terms outside instead of just one absolute value equaling another absolute value. So kind of the approach we're going to take is isolate one of them. So we'll isolate this one. So let's add 6 to both sides. And you'll end up with the absolute value of 4x plus 3 equals 14 minus the absolute value of 2x plus 1. Okay? So let's go ahead and break this down into the two equations that we need. So 4x plus 3 equals the positive side here, which is 14 minus the absolute value of 2x plus 1. And then I have 4x plus 3 equaling the negative side, which will be negative 14 plus the absolute value of 2x plus 1. All right, well, you'll notice both of these equations still have an absolute value expression. So let's go ahead and isolate each one and break it up into two separate equations. Okay, so I will subtract 14. So 4x minus 11 equals negative, or the opposite of the absolute value. So let's go ahead and divide by that negative 1 so we can isolate that absolute value. And so we'll have negative 4x plus 11. And when we break this into two equations, I'll have my 2x plus 1 equaling my positive side, which is negative 4x plus 11, and my 2x plus 1 equaling my negative side, which will be, and when we negate this, we just change the signs, so positive 4x minus 11. Well, okay. Well, it looks like we're going to end up with several equations here because I had to do this one twice, and I'll end up doing this one twice as well. So let's solve for x. So I'll add 4x and get 6x equals, and subtract 1 to get 10. So x equals 5/3. So there's one possible value. So here, let's go ahead and subtract the 2x, and we'll get 2x over here, and we'll add 11 to get 12. So it looks like 6 equals x, or x equals 6. So there's a second possible value. Let's go ahead and leave those for a second, and we'll come back to those in a moment. Let's go ahead and break this down. Well, first we have to isolate the absolute value. We'll add 14 to both sides. So 4x plus 17 equals the absolute value of 2x plus 1. And again, now we need to split this into two. So we have our absolute value, which is 2x plus 1, equaling the positive side, which is 4x plus 17. Also, I have the 2x, the plus 1, equals the negative side, so it's negative 4x minus 17. Let's go ahead and solve both of these. So subtracting 2x gives me 2x on the right, and subtracting 17 gives me negative 16. So it looks like negative 8 equals x, or x equals negative 8. And solving this one, add 4x to get 6x, and then subtract 1 to get negative 18. So it looks like the final possible value of x equals negative 3. So goodness, we have 4 values here. So let me go ahead and kind of collect them all here. X equals possible values 5/3, 6, negative 8, and negative 3. And I say possible values because just because they've been yielded by the progress here, or the procedure I've used, doesn't mean that they all will work. You still can have extraneous solutions here. So let's go ahead and let me rewrite the original equation so we can plug them in and see what works and what doesn't work. Okay, let's try x equals 5/3 first. Okay, so in this absolute value, 4 times 5/3 will be 20/3, and 20/3 plus 3 will be 29/3, and the absolute value of that is positive 29/3. And from that we'll subtract 6, which is 18/3. So I'll have 11/3 on that left side. And the right side, okay, so 2 times 5/3 will be 10/3, plus 3 is 13/3. So this 8 will turn into that, 24/3 minus the 13/3, so 11/3. So actually this 5/3 works just fine. So we like that. So one value checked and one value of x that works. So let's try x equals 6. 4 times 6 is 24, plus 3 is 27. Absolute value minus 6 is 21. And 2 times 6 is 12. 12 plus 1 is 13. Absolute value is 13. 8 minus 13, ooh, negative 5. No good on that one. So 6 is actually not a value that works. Okay, let's try, let's see, negative 8. So 4 times negative 8 is negative 32, plus 3 is negative 29. Absolute value makes positive 29. Minus 6 is 23 for that left side. So 2 times negative 8 is negative 16, plus 1 is negative 15. And then, so positive, 1 to the absolute value. So 8 minus 15, negative 7. Ooh, that does not work either. Okay, so we're going to X out that one. So let's try x equals negative 3 now for our last possible one. So 4 times negative 3 is negative 12, and plus 3 is negative 9. Absolute value is positive 9. Minus 6 is 3 on that left side. And 2 times negative 3 is negative 6, plus 1 is negative 5. Absolute value is positive 5. 8 minus 5 is 3. So that one does work. So we have two values for x. We have positive 5/3 and negative 3. And that will be the solution for that second example that has two absolute value expressions in one equation. Well, just to be thorough, let's go ahead and look at this equation. We'll kind of investigate it a little using this property again. So the absolute value of x equals the square root of x squared. So let's go ahead and change this absolute value equation into the square root equation. So we have our 4x plus 3, and that'll be squared under a radical. Minus 6 equals 8 minus, and then we have the square root, and that'll have 2x plus 1 squared underneath that. So we'll have to start by isolating one of these square roots. We're going to add 6 to both sides, and we'll have to square both sides then, but it won't take care of both radicals. We'll have to isolate the leftover one and square again. Anyway, we'll end up with a quartic polynomial, and let me just go ahead and write that quartic polynomial down, because I want to show you that it actually does work this way. It just might not be very practical to work through and solve it this way, because as you'll see, this polynomial equation is a little bit crazy. Okay, so big coefficients, degree 4, but we can factor out a 48 as a greatest common factor, and when I finish and factor the entire polynomial, I'll end up with, and you might even recognize some of these numbers as I start to write them down. So x equals negative 8, negative 3, 5/3, and 6. Well, if you will remember, I'll grab this piece of paper, those were the values we got here, 5/3, 6, negative 8, and negative 3. But what we saw was that 6 didn't work and negative 8 didn't work because they ended up being extraneous solutions, and the negative 3 and the 5/3 were the only two that worked when we plugged them in. So you'll notice the exact same thing happened. We had 4 possible values, 2 worked and 2 didn't work. So again, just kind of a different property that we can use to solve these equations, knowing that the absolute value of x is also the square root of x squared. So that's kind of an introduction or a way that you can solve absolute value equations that have multiple absolute value expressions contained in them.